All right. Hope everybody's doing well. Welcome. If you're here live, please feel free to use the chat window for YouTube. Let me know if there's any problems with audio or video, or if there's something I can fix. Just sort of in the beginning stages of tweaking everything. But on the plus side, the board has finally just approved us to use conferencing software. We are limited to Google Hangouts and Microsoft Meets. But that way, at least I can get some audio. So if you guys have any questions, you can talk to me that way. So maybe we'll shift this whole platform back over there. Finally, we'll see. I think the registration problems that people were having with Microsoft Meets will go away because they'll take off the restrictions on board emails. But we'll see. So today I want to go over graphing linear systems. So graphing linear lines. It's something that we've been working on for the last week and a half. It's something that we were just about to dive into right before the break. Obviously, with the disruption, we haven't been able to get there. But I hope everyone's doing okay with it. The quizzes seem to be going all right. But I do just want to review graphing from an equation in slope-intercept form. And I also want to go over writing the equation in slope-intercept form when given a line. So let's start with graphing from slope-intercept form. There are two major forms to write linear equations. There's the slope-intercept form. There's also standard form. Standard form we'll talk about a little later. It's one where the x and y variables are on the same side of the equation, and we will have to go between the two. So we will be using some algebra to solve linear systems, and we'll be doing that through converting between one form and the other. But for now, let's just focus on slope-intercept form because it's much easier to graph in slope-intercept form. Hey. So we have y is equal to 7 over 2x minus 2. And the two big things you have to know about slope-intercept form is that we call them slope-intercept form because the form gives us the slope and it gives us an intercept. Specifically, it gives us the y-intercept. So it gives us two major pieces of information. And those two pieces of information are actually all we need in order to graph this particular line. Because I only need 2 points or a slope and a point. So I know that my slope is 7 over 2. And I remember that slope is equal to the rise over the run. Or in other words, slope is equal to the change in the y, this little triangular symbol means change in, over the change in the x. So the rise is 7 and the run is 2. So for every 7 units that I go up, and it's up because this is positive 7, then I go 2 units to the right, and it's to the right because it's positive 2. Left is negative, right is positive, down is negative, and up is positive. And that sort of makes sense because it's the same thing on a coordinate grid. Right is positive, left is negative, up is positive, and down is negative. Okay, well that's nice, but I need a reference point to start at. Well, I have the y-intercept. So I'm going to use the y-intercept as my 1 point. And I'm going to say that this is the y-intercept, so negative 2, so the value must be, well, I know that the y-intercept is a point on the y-axis. And if it's a point on the y-axis, the x value has to be 0 because every single point on the y-axis has an x value of 0. So it's going to be 0 and negative 2 because we write coordinates x and y. So I'm going to draw a point at 0 and negative 2 right here. So that's where the line crosses the x-axis. Well, that's not enough to draw a line. I need at least a point and another point, or a point and a slope, and I'm going to use the slope to find another point. So the slope tells me that for every 7 units that I go up, I go 2 units to the right, because for every 7 units of rise, I have 2 units of run. So I'm going to start at my y-intercept, and I'm going to go up 7. 1, let's see here, I'm going to go 1, 2, 3, 4, 5, 6, 7. So I'm going to draw a point right there. And then just a little point because it's not a real point. It doesn't exist on the line. And then I'm going to say and then I go up 7, and then I go over 2. 1, 2. So that's where I want to end up. So that's where my real point's going to go, right here. Everything else can get erased. And now that I have 2 points, that's all I need to draw a line, and I'm going to draw a line right through those 2 points. And don't forget, this line does continue forever, and to indicate the fact that it continues forever, we put arrows on each side. Okay. Let's do it one more time. Let's do it over... Let's do it here. So I have my slope. But if slope is rise over run, there should be 2 values. There should be a change in the y and the change in the x. There should be a rise over a run. But there is no run in this case, there's just a value. But I can always make it a fraction by putting it over a positive 1. So I do have a run, we just don't write it down when it's positive 1 because mathematicians don't like to do that. It's just in proper form because we're lazy. So I have a rise of -6. So I'm going to go down -6. And then we have a run of positive 1. So I'm going to go to the right, positive 1. So I'm going to go down 6, and I'm going to go to the right 1. But I need a starting point. And my starting point is going to be my y-intercept, and my y-intercept just happens to be positive 3. So I know my x value of every y-intercept is 0, so it's going to be 0 and 3. So 0 and 3 is going to be right here. And then I'm going to use my rise and my run, my slope. So it's a -6, so it's a rise of 1, 2, 3, 4, 5, 6. And then 1 to the right here. So that's where I'm going to end up. Right here. And then I draw my line. And I draw my arrows. Because that line continues forever. Hey guys that just joined, thanks for stopping by. If you do have any questions about this stuff, please just ask in the chat box and I will definitely answer it as soon as I can. This is live, but there's about like a 10-second delay. All right, one more, and then we're going to go on to... Then we're going to go on to doing the opposite. We're going to write the equation from the graph. All right. So this one's weird. I don't have an x. I don't seem to have a slope because my slope would usually look like this. I just have a number. And the reason that happened is because the coefficient in front of the x, there is a coefficient in front of this x. There is something there. It's a coefficient x minus 5. But the number in this coefficient is such that this whole term became 0. So it's something times x is equal to 0. And the only thing that I can multiply x by to get 0 is 0. So the slope is actually 0. The slope is 0, which canceled this out, and all we were left with was x equals -5. And a slope of 0 means a horizontal line. So I know this is a horizontal line. This is a slope of 0. If the line's increasing as I go from left to right, it's a positive slope. If it's decreasing as I go from left to right, it's a negative slope. If it's exactly horizontal, it's right smack in the middle, so it's a slope of 0. If it's a vertical line, there actually is no slope, and we call that undefined. So the slope is undefined, and we would actually write that it's undefined. So I know it's a horizontal line. Okay, well, where does it cross the y-axis? Well, it crosses the y-axis at -5. So I know that I'm going to have a point here. Well, the only horizontal line that crosses the y-axis there is right here. So whenever you don't have the slope listed, when it's just y is equal to a value, it's because every point on this line is equal to y is equal to 5. So that's the only piece of information that I really need to know. Because no matter where I draw that point, it will always be a y value of -5. And don't forget to draw your arrows because that line goes on forever. All right, let's do the opposite. Let's do equations from the graph. So this is the same thing, only backwards. So y is equal to mx plus b is my general form of the slope-intercept form. Oh, is it necessary to draw arrows? So the only case where it's not necessary to draw arrows at the end, so this is the question, do we always have to put arrows on the ends of the line? Usually. The only time it's okay not to is if there's restrictions on the line, or if the line goes right to the end of the graph, that means the line goes on forever. So if the line is right at the end of the graph, if you want to draw it right to the borders of the graph, then you don't need arrows. But any other time, or you can't even put arrows just to be safe. It's nice to put arrows just to say that, hey, look, I know that this line is infinite and it goes on forever. The only time you wouldn't is if there's restrictions on the line. But we'll deal with that later in the course. And actually, because of the disruption, we might not even get there at all. Yeah, I record everything and it's going to be on my channel. So you'll be able to watch it later. Okay. So y equals mx plus b. M is my slope, and it's going to be in fractional form, even though I might not write it like that. If it's a denominator of 1, I won't indicate that. And I have my y-intercept. Well, let's start with the y-intercept because that's the easiest one. Where does this line cross the y-intercept? Well, it crosses at -1, so the point is 0, -1. So I know that this b value is going to be -1. Well, now I need my slope. Well, I'm going to pick 2 points on this line. And I'm going to put, it doesn't matter which 2 points I pick, I just want to pick 2 really nice points. So 2 points that lie on values that are easy to read. So I don't want like 2.25 and 3.6. I want nice round numbers. So I know that it crosses the y-intercept is 0 and 1, so that's going to be 1 point. And then it looks like it crosses right here. So this is the point 5 and 1. So 5 and 1 and 0 and -1. And now I'm going to find out what my rise and my run is between those 2 points. Because it doesn't matter what the 2 points are, the rise and the run should always be the same. So let's start, and it doesn't matter if I start here or here, and I'll show you that in a second, but I'm going to start here at the y-intercept. And I'm going to start with my rise. In order to get from here to here, the game is I can only go up or down or left or right. I cannot go diagonal, but I have to get from this first point to this second point. And I'm going to start with a rise. I'm going to start with a rise, and I'm going to go up 2, 1, 2, right to there. And then I'm going to go to the right as many as I need. So I'm going to go up 1, 2. So that's as high as I need to go. So that's a rise of 2. And then positive 2 because I went up. And then I'm going to go to the right 1, 2, 3, 4, 5. So I drew a little arrow there, and that arrow has a rise of 2 and a run of 5. So rise of 2, a run of 5, and so my slope is rise over run, which is a rise of positive 2 and a run of positive 5. My slope is 2 over 5, so my equation is y is equal to 2 over 5x minus 1. Let's do it again. That was a positive slope. Let's do a negative slope. Oh, I did want to show you that it doesn't matter which points I start at. If I had chosen to start at this point, I can get the exact same slope. I'm going to go, and actually I'm going to start with my rise again. So I'm going to start here, but this time I have a rise of -2 because I have to go down. So that's a rise of -2. And then I go to the left, so that's a run of 1, 2, 3, 4, 5, but it's a run to the left, so it's negative, so it's -5. So here my slope is rise over run, which would be -2 over -5, but I know that any negative number divided by a negative number is a positive, so these would cancel out, and I would get positive 2 over 5. So it doesn't matter where you start, as soon as you're done simplifying the fraction, you'll always end up with the exact same slope, regardless of which two points you choose and regardless of what point you start at. Let's do this one right here. We'll go a little bit faster on this one. So this is a y-intercept of -1. So I know that my b value is -1 again. And I want my slope. So this is a nice number. It's always nice to use your y-intercept because it always, usually with these types of questions, it always lands on a nice whole coordinate. So -1, and where else is it good? Where can I go? Oh, this works. Either here or here or here or here or here. It doesn't actually matter. Let's do this one over here. And I want to know my rise and my run. So I'm going to start with this point. My run is going to be negative, so I'm going down 1, 2, 3, 4. So it's a run of -4. Sorry, a rise of -4. It's a rise of -4 and a run of -2. Oh, +2 rather, because I'm going to the right. So I have a run, I have a rise of -4. I have a run of +2. My slope is rise over the run. However, this is not a reduced fraction. I want to make sure whenever I'm dealing with fractions that my answer is always in the reduced form. So I'm going to find the lowest common multiple, which in this case is 2. I'm going to divide both -4 and 2 by 2, and I'm going to get -4 divided by 2 is -2. 2 divided by 2 is 1, and in fact, I don't even have to write the 1 because it's the denominator. I can just write it as -2 because -2 divided by 1 is -2. So what's my slope? Well, my slope is y is equal to -2 is my slope, x minus 1. And I think that's it. I did only have a half an hour today, so I'm sorry. I just kind of wanted to test this out to see if it works. It does work. Like I said, we are now approved to go to Google Teams or Google Meets or Microsoft Teams. I'm going to see how many people can get access because maybe we'll go there because at least that way I can get your audio, which makes it a lot easier to ask questions. But I hope this was helpful, and I will get the rest of your Google Form quizzes marked. If you have any other questions, you can message me either on here or on Microsoft Teams or Google Classroom. I'm sitting at home all day, so I'm checking all the streams. So good luck, and we'll talk to you guys soon.